Well, hello everyone, and welcome back to Adrian's Digital Basement 2. On today's video, we have this monitor, and this is an Acorn Computer RGB Vision II, which is unusual because, well, honestly, I had no idea that Acorn sold anything in the United States, let alone an RGB monitor. Looking at the front of the monitor, we have an Acorn Computer badge, RGB Vision II logo, and we have a brightness knob here, which just seems to work well, and then a power switch, which is a push-on, push-off switch. This monitor sports a 12-inch CRT with a relatively dark phosphor, which is kind of nice. The shape of the monitor is pretty compact and very box-like, and looking at the side of the monitor, it's in really good shape. It's probably slightly yellowed, but honestly, I just gave it a slight cleaning, and it looks really good. On the back of the monitor, we have a power cord that just has a standard 2-pin plug, not grounded. And the rest of the back of the monitor looks pretty typical. We have a focus control here, along with some adjustments that are available through the back of the case. There's that Acorn Computer logo again and 12-inch color display, model number KS124-301S-UN, AC 120 volts, 60 hertz. So this is definitely a monitor that was designed for the US and Canada market. There is the FCC ID, and as you can see, made in Japan. There's Acorn Computer Corporation's address in the United States at 400 Unicorn Park Drive in Woburn, Massachusetts, 01801. Interesting because I'd kind of say that any kind of Acorn monitor is kind of a unicorn. So the fact that it came from Unicorn Drive or Unicorn Park Drive, yeah, pretty funny. Take a look at the inputs here. There's a mode selector switch with a 1, 2, and 3, and then we have 1 and 3 on this DIN connector, and then we have this connector, which I don't remember the name of again, but we recently saw it on that Panasonic television that I worked on the second channel as well. This is definitely a Japanese type connector that is used on a lot of Japanese monitors in the early 80s. Didn't really get much traction outside of Japan though. But yeah, you're bound to see this on some Sony PVMs or broadcast monitors have this as well, and it's used for like videotape connection. So that's a composite signal, but this is most likely or most certainly an RGB signal. Here's the AC cord that goes into the monitor, and there's even a ground lead right there, which is kind of typical because in Japan, a lot of devices that would normally be grounded in the rest of the world only have a 2-pin plug, and then there's an extra wire that you might attach for a ground. I wanted to show that on the top of the monitor, which is just basically a flat surface, there are these 2 stickers here. Personally owned equipment. This equipment should not be entered into the AEMS/MERS database. As far as I'm aware, this has something to do with the VA medical system or hospital system here in the United States. VA is the Veterans Administration, and if you are a veteran, as in you served in the armed forces, you can get medical care pretty much for the rest of your life from the VA medical system here in the US. They operate a whole system of hospitals. Someone brought it in to work, I guess, and was using it for, well, some purpose. And if we look here, exposure for the RGB screen, Fujichrome ASA 100. So I'm assuming that this was connected to some type of a computer system, and it was used in conjunction with photographing whatever was on screen and put onto film. So maybe there was some kind of medical equipment that used some old machine or old computer that was RGB, and they use this monitor for that purpose. Now in this video, I want to take this thing apart. Let's take a look inside, but I also want to test this monitor out to see if it's working. And I did a little research to try to figure out what the deal is with this monitor. And as I kind of suspected when I first saw this monitor, I thought that this might be a Taxan monitor, and it was just rebranded for Acorn. Taxan was a brand that was popular in the US in the early 80s, and they actually had a whole line of different peripherals for microcomputers, including really high quality RGB monitors, and actually they even made RGB cards for the Apple II. And I actually have a Taxan 80-column video card right here for the Apple IIe. I've had this for quite a while and I've never actually tested it, but my assumption is that this card would have been paired with the Taxan version of this monitor for awesome, super sharp 80-column text. Now in the box for the Taxan card, I do have the original card, and I have the original manual and floppy disk as well. But the problem is I don't have the interface cable that goes to this monitor. So because I lack the interface cable for this, let's first see if we can find the manual for this monitor, and then figure out if I can hook something else up to it, maybe with a cable that I already have, as opposed to trying to get this Apple IIe card working. And after some quick searching, I found a post here on Stardot talking about this monitor. Here it is, the Acorn branded Taxan RGB Vision III. Looks like there was a recent eBay sale, and this is actually earlier in the year. And then someone has scanned in the manual for the original Taxan monitor and uploaded to archive.org. Thank you very much to whoever did that. I don't know why I'm talking over the monitor like this. How about I just move it out of the way so I'm not leaning over it. One thing about this monitor is it's a small 12-inch monitor, but I can't believe how heavy it is. It is so ridiculously heavy. It must be filled with like a metal chassis in there, because there's just no other way. If this thing were just plastic, that it would weigh as much as this thing does. All right, so here's the manual that's on archive.org, and yeah, that's it. I mean, the only difference is really it has that Taxan branding there, but RGB Vision 3 is exactly the same as on this Acorn one. So they just simply slapped a different brand sticker on the front and the back and called it good. Looks like the Taxan products sold in the US were, well, at least the monitor here was sold by Kaga Electronics out of Japan. Let me take a look in the manual here for the Apple IIe 80 column card and see if this is also Kaga. No, it's not. This is Taxan Corporation out of City of Industry in California. So I have a feeling that even the Taxan monitor here was a rebranding of a Kaga Electronics monitor that was sold under the Taxan brand in the US, which was then rebranded again to be Acorn. Either way, let's try to figure out what these different input connectors are on the back of the monitor. So it looks like this thing supports Apple computers, PCs, and NEC, so probably like PC 8800, 8801 machines. Here's a diagram of the various connections and controls on the monitor. And here it talks about the 3 different modes of operation. So mode 1 is for the PC. Looks like it's RGB plus intensity. Hopefully it actually supports brown properly. And looking at this connector here, this DIN, I realized that it's exactly the same as the RGBI input on the 1084, the ones made by Philips, the boxy one that I typically show on the channel, which is great. That means I already have a cable for it. And looking at this, it appears that this is the same. So grounds on pin 6, yeah, I kind of went back and forth, and it appears that the pinout is exactly the same as this mode 1 on the Taxan/Acorn monitor. Now looking at the mode 2 connector, it says it's for the Apple II and the PC 8001, so that's that Japanese computer that I don't think it was ever sold in the US. It appears like it is analog RGB. I don't quite get how it says 1 to 2 volts peak to peak, where typically an analog RGB signal is just 1 volt peak to peak, or TTL, so it supports both. Interesting. It must like clamp the inputs or something to not overload those input amplifiers for the analog signal. The mode 2 appears to be using, and if we scroll over here, it appears to be using that multi-pin connector. So not the DIN connector, but that rectangular connector. Looking at the pinout here, there's no intensity bit, which would imply that it either only supports 8 colors if it's TTL input, or these inputs are analog. The Apple II, of course, is a 16-color machine, if you're looking at the low-res modes, low-res graphics that is. So that Taxan card that I have, I suppose, outputs an analog RGB signal. I've never actually tested that card to see if it works or not, or figured out how to even interface it, because it doesn't even have a little harness or anything. It just has a pin header on the board. But this is going to be interesting. If this monitor works, it's definitely going to be something I'm going to have to try out on this monitor. And then we have a third mode on here, which I'm pretty sure is going to be using the DIN connector, and it is indeed. And look, it says it's for the Apple III, and it's XRGB, and XRGB is Apple's digital TTL RGB mode that has a similar signaling to CGA, meaning it's RGB plus an intensity bit, but the color mapping is completely different. But yeah, just know that if you're going to try and hook an Apple III, which does support RGB color, up to a TTL monitor, if you hook it up to a CGA monitor, I think it will work, but the colors are going to be all wrong. It needs to support XRGB, which is really cool because I actually don't have any monitors at all, even though I have a ton of monitors, I don't have any that support XRGB. And the only thing that I have that supports XRGB is this, which I'm trying to get into the field of view. This is the RGB to HDMI. This supports it because I worked with Ian on the Apple II profile to implement an XRGB mode for anyone who's hooking up an Apple III to this thing. It will have the proper colors. Although now that I think about it, I think I have an Apple IIe RGB card from Apple themselves, and I think it uses the XRGB standard, as opposed to probably the Taxan card, although I'm not really sure. So actually, if you happen to know about these different RGB standards the Apple II used, like on the Taxan card, please put that down in the comment section below so I can get a little insight. Anyhow, moving on in the manual, take a look at this. So turn it on, set the mode switch. After a brief warm-up level, adjust the front panel brightness control for a comfortable viewing level. Lower levels will increase the tube life and lessen screen burning. Yes, that is for sure. I think this Taxan monitor uses a pretty high resolution monitor, like the dot pitch is very fine, which means that you kind of have to run the brightness high to get a very vibrant image. That's one of the trade-offs you get between a high-res CRT and a low-res CRT. You get more brightness and color saturation on a low-res CRT like the Commodore 1702, but a high-res one like this can result in a sharper image, but you get a dimmer picture. You can definitely tell that this manual came from a Japanese company when you have these little pictures like this. Maybe this was a product of the 80s, but this seems very typical. I've worked on many Japanese cars, and inside the service manuals, it has funny little pictures like this, which I love. Incidentally, there are no user serviceable parts inside the monitor, so don't go opening it up like I'm about to do. It appears that this monitor supported a glare shield of some kind, and yeah, I'm kind of not surprised about that because I could see little, I don't know, little clips or something on the front where I guess you slide it in and drop it down and it stays in there, but it doesn't seem like it's installed. And I noticed on the eBay listing from that Stardot post that it didn't have any kind of shield, and even the picture on the front of this manual didn't show any kind of shield. Oh look, the glare shield is not provided for non-glare tube face monitors. Well, this CRT had etched glass, which means it's kind of already anti-glare. So I guess if it has a shiny CRT, they would give you some kind of glare shield too, well, or would have been pre-installed on the monitor. And here are the specifications for this monitor. So yeah, 12-inch 0.63 dot pitch for the RGB Vision 1, and then 4.7 for the 2, and this is a Vision 3, so the highest resolution version of 0.38 dot pitch. And you might remember, like in the VGA monitor days, when VGA monitors started getting pretty high resolution, you'd often see like 0.28 dot pitch or 0.25 dot pitch, because the lower that number, the higher resolution the monitor can resolve. It seems to have 3 ICs in there, 29 transistors, and 36 diodes. Like, that's some kind of awesome feature there. And there it is, display colors, more than 256 or 8 colors. Well, analog RGB has kind of like an infinite number of colors, so that's pretty funny that it's more than 256, but that does definitely confirm that it is an analog capable monitor, which is pretty awesome. It means it will work with the Apple II GS, and all the TTL inputs will work with, well, everything that's TTL, C128, IBM PC, CGA and EGA cards. I think the BBC Micro uses TTL output as well. I think it's only 8 colors, so it doesn't use the intensity bit, but it's still TTL. And of course, the list goes on, the Atari ST and Amiga and stuff like that. It's all analog RGB. And that's it for the manual. So let me grab the monitor, let's put it back on the bench and take that back cover off just to make sure everything looks good inside, and then we'll power it up. Let's put this on its face here because I can see there are a couple screws right here. Those need to be removed. And with old monitors like this, you don't want to just put it straight down onto a desk because you could scratch up the front bezel because it's usually painted. Not to mention this has these knobs that stick out, like the power knob and the brightness. So I don't want to place it flat on the desk as well because you could be putting pressure on those unnecessarily. While I have the monitor down on its face, take a look at this. Manufactured February 1984. And it looks like we have the same model number and stuff that we saw on the back, but there is the date of manufacture. So this is an old monitor, definitely old. Probably was pretty expensive when it was new. All right, so let's just get these 2 screws out, then I can put it face down on the front. There was a nice little crack there as I was turning the screw. Now the interesting thing is, I remember getting one of these monitors years ago. It was actually from the same person I got the FieldFound 64 from, that old machine. And the interesting thing is, the one I got from him was a Taxan monitor, and I think it was a Vision 3, just like this, but it had been left outside for years and years and years. And while it did turn on and work, if you can believe it, even though it was extremely rusty and full of mud, the CRT was very, very worn out and was very dim. So you had a picture, but it was really not very usable. And the condition of the case, it was completely like baked and cracked and everything. So I actually had to e-waste that monitor. I did save a couple components out of it, but generally the rest went to e-waste. This is how I usually do it. I have it on my lap, and the case just very easily came off. I'll just feed the power cord right through it. Let's see how this looks. Hopefully it's nice and clean on the inside. So yeah, look at all this heavy metal right here. I would kind of explain, oh, it's so clean. This thing has to be low hour. I'm completely flabbergasted at this. The one that I had, like I was talking about, that was all rusty inside, it was so worn out and just used up. This thing, on the other hand, is spectacular. All right, so let's take a look at what's going on here. So the flyback transformer is down there, and the high voltage comes out of it on this wire right here and goes up into this device. And I'm thinking that this is either a tripler, so it takes the high voltage of, say, like 5,000 volts and triples it to 15,000 volts, but it also might be a diode. So you need to take the AC that comes out of the transformer and convert that into DC, because something like the CRT is simply a large capacitor. Capacitors work on DC. So I'm not quite sure if this is the tripler or the diode, or maybe it's both. Either way, what happens is there's an output wire, which is this thing right here, and it goes into this little assembly here with the two knobs for the focus and the screen. And what's happening there is this is going to have a bunch of resistors, a voltage divider that takes whatever the 25,000 volts or whatever the high voltage is and brings that down to the appropriate focus and screen voltages that are going to go to the back of the CRT here on the neck. And then there's an output right here, which is going to be pretty much unchanged. I think it just goes in and comes right back out. And that is what actually goes, we turn this like this, right here to the CRT on the high voltage anode cap. Now you can see that this thing is looking like unbelievably clean inside. Kind of looks like this thing is barely used. So if this was just used for like that photography of the screen, maybe they turned it on and then quickly turned it off. I don't know, but either way, it's amazing. It looks so new and nice inside. I'm completely shocked. Looking around a little bit more, we have the deflection yoke, and I mean, it's not even dusty or anything. There's a little bit of the black soot on here that comes from the high voltage of while the monitor's operating, but it's extremely minor. Considering this thing is from 1984, it's kind of staggering to me how clean and nice this thing is on the inside. Looking down here at what is called the neck of the CRT, we have this convergence assembly right here, which I'm not going to touch. And then right here, you can see the little bit of the glass tube that is then in a tube socket on the neck board. And when you have a high resolution CRT, which has a low dot pitch, like we know this one has, it seems that these seem to have a larger connector on them and a larger diameter of the neck here. I don't know why that is, but lower resolution CRTs seem to have a smaller diameter. So that's just something to look for. If you're thinking about doing a tube swap, to swap in a different CRT, you know, this has to be not only 12 inches, but also has to have the same size neck and connector as well. Taking a look at the side of the monitor, we have a transformer here. So this is an isolated design, which means it's not a hot chassis. So that's pretty nice. And that'll go into some kind of voltage regulation circuit, which is probably what's happening on this board. There's probably some big power resistors back there, which we can't really see, that are going to be bleeding off the extra voltage. And that will then go as the B+ into the main PCB. Here's the label for the CRT, and it's made by NEC Corporation, made in Japan. 320DMB22, so 32 centimeters in size. And like, look at this label. It looks basically brand new. Now, it's going to be hard to film, but what I'm looking for down on the main PCB is anything that looks like it's, well, not looking good. So something that maybe is exploded or leaked or whatever. And I don't really see anything at all. It all looks basically brand new. Now, some monitors have that kind of glue stuff they put around the components that can corrode nearby components. So they might use some kind of gunk to stabilize the capacitors. And then if it overflowed onto like diodes or resistors, it actually can become, what's the right word? Hydrophobic? No, hydroscopic? Whatever the word is, it absorbs the moisture in the air and it becomes corrosive and conductive to the things around it. I don't see any of that on this monitor whatsoever. So I'm going to say that this thing is pretty much good to go for testing. All right, for testing, I'm just going to make sure this monitor is turned off by putting the power switch in and out, and it is. I'll just bend this a little bit. Wow, this isn't even a polarized connector. But you know what? You don't need a polarized connector because this has a transformer, which means it's an isolated design. Alrighty, and I'm going to reach to the front, and I'm going to turn this on, and we'll just listen and watch for anything bad happening when I push the power button. Here we go. Okay. Sounds normal. We have high voltage definitely running right now on the monitor. No abnormal sounds whatsoever. And if you take a look at the reflection of the screen on the LCD screen there, you can see sort of a moving pattern, which implies that this thing is freaking working. And I can confirm that. I just looked on the front and I can see it's white. The image is white there, which looks good. So I'm just going to turn this off, and I think I'm going to put the cover back on, and let's give this thing a proper test. Okay, for testing this thing out, I have a CGA card here plugged into my 386SX motherboard. And the monitor I'm going to keep open in case I need to make any adjustments to these controls here, especially the drive controls or the focus, stuff like that. And for connecting it, I have this, which is an interface or adapter cable I made for the 1084, so RGB TTL, and it has that same DIN connector that this monitor has here on the back. So I remember that selection 1 was the one you needed for the PC, so we'll plug that in there. And I have a RGB cable right here. Well, it's not RGB, it's just a 9-pin regular cable. So we'll connect that up. I switched over from NDI to my Sony camera because it has a fixed 60 hertz shutter speed, which is appropriate for filming a CRT. It's not perfect because I wish I had a camera that was a little better at adjusting the exact sync rate, but it's gonna be good enough. So we'll turn this on. Power LED comes on. I hear the high voltage running. And for this, let's see here. So it's free running. You can see that bar that's moving up. I don't see that obviously. When we turn this on, it has gone black. And oh, there we go. Right, okay, so obviously it's in 40 column mode, which is why we're seeing it all stretched like this. And it looks like those controls are probably a bit out of adjustment on the back of the monitor. Going to the BIOS, it looks like it's definitely working, although the geometry is definitely off. But first we're gonna let this thing boot up into DOS, and then I will adjust the geometry. Let's run Jim Leonard's CGA compatibility test suite, which of course, because that's a CGA card, it should work well. Pretty sure he added a monitor calibration thing for me. Let's see what he added. One thing I am seeing is that the dark yellow, which on CGA should be brown, and maybe I should zoom up so you can see that a little bit better. It's definitely dark yellow, but it looks exactly the same as the reds, as dark red. So therefore this text here, which I think should be brown there, is not readable. So it's not perfect when it comes to PC colors, but I gotta say that the overall color saturation is pretty good. Although it's funny that the green, red, and the cyan, like these colors are much brighter than the white over here. This white is a little dim looking for whatever reason. I'm also noticing that the dimness is actually just more substantial over on the side here, that it's all brighter here and then it dims out as you get to the side. So maybe there's some capacitors that require a little bit of help in there. Might be some that aren't working so well. Maybe it'll come back though, just running this monitor, because maybe this thing hasn't been used in forever. But if the capacitors are weak, then what's gonna happen is as the beam current is sustained all the way and starts to kind of fade away as it gets to the side over here. So that's quite possible here. And then here's the yellow and brown. I mean, I guess there's, I don't know, it looks pretty much identical. And this knob here doesn't seem to be a separate contrast. There's only a brightness knob on the front here. There is not a contrast knob. Okay, I'm realizing now that this is the old version of the CGA compatibility test suite because this test pattern is the old one that's on here. Either way, this is good enough for me to start adjusting some of the geometry to try to dial the monitor in a bit better. So I'm gonna use some tools here that are non-metallic for adjusting these controls, even though the controls actually are plastic, and so it's not like I'm touching metal to metal. But let's see what we got here. So we got side to side. That is vertical hold right there. And then here is the vertical size, which is obviously too low. So we need to bring that up a little bit. And yeah, that looks pretty good. And I need to bring in the width. Now the width on this monitor is a width coil, and I have to use a tool like this, which is sort of like a hex tool, plastic one. Because if you're adjusting one of these controls while the monitor is energized, if you put a metal tool in there, there's a lot of, I don't know, high frequency voltage running through there, the deflection essentially for the monitor, and it will heat up and do bad things. So you really need to use a plastic tool. So let me turn this, and hopefully this works. This thing might be broken because I'm turning it and it doesn't seem to be doing anything at all. And I'm definitely have the tool in there. So this is probably a fault. Yep, nothing is changing whatsoever. And you know, I'm turning this control and I can see the slug moving in and out. And it doesn't feel cracked. It feels like it's working without issue. but we're not having any effect at all on the screen. So there's got to be a fault, and I think it's probably not the inductor, which is what's controlling the horizontal size here. It's probably something else on the PCB, like some other component that's around it that's gone open or bad, and that has stopped that control from working. I wish I had the schematics for the monitor, because that would certainly give me a very quick indication of what I could look for to try to figure out what's broken. I wanted to tilt the monitor on its side so I could see if I could see the PCB. And as you can see, lots of shielding on here. So I'm going to try to pop this off. It looks like it actually has some tape and then has some clips. So it's not soldered on, which is nice. That's a very nice thing, actually. Ooh, and indeed, it's a nice design where these just sort of clip out really easily. The only negative is that this part of the chassis here has this sort of heat shield or structural rigidity or something going on. So I just need to take these screws out, I think, to get this out. And in fact, I don't know if it actually screws into this shield or not, but the tape is going under it. You know what? Before I take that out all the way, I'm just going to peel this tape off and try to get this cover off without getting this structural part apart. This is what holds the whole like flyback voltage assembly. Oh, look, you don't need to do it. Okay, cool. There we go. That is really easy. I really enjoy that. Thank you very much, Taxan or Kaga, for doing it this way. Now, looking at the board here, right here is that inductor that is for the width, and it looks like it's connected to these 2 points on the PCB. So first off, I'm looking for any kind of like bad or broken solder joints, which I'm not seeing. What I'm going to do, though, is I'm going to connect my meter across here, the LCR meter. I just have to grab that. The LCR meter is designed for checking capacitance. It's this thing right here, capacitance, but also inductance. All right, so first thing I'm gonna do is I'm just gonna check for any voltage across there in case there's anything residual in the monitor, and there's not. So let's switch over to ohms. And yeah, we're getting 0.3 whatever, which means that that inductor should be connected, because typically an inductor, when you have the multimeter connected, it's gonna look like it's a short. With the LCR meter connected, we have 102 microhenries, I think it is. All right, and I'm gonna put this adjustment tool in there. Wow, and I'm turning it. Oh no, it's having an effect, look at that. Not much of one. I don't really know what the range should be on this. No, it's okay, it's working. All right, so let me figure out what the minimum and the maximum is on this particular control. Turning it clockwise. It's going down. You don't want to do it too far because there's like a slug inside that kind of moves back and forth. You don't want to like have it come right out of the actual, I don't know, this variable inductor. I think I've reached the end there. It's about 68 or 69. So I'll just write that down, 69. And now I'm going to turn it counterclockwise. So it definitely seems to be working. Like we're almost at 200 now. Fact is, this is working, and there's just got to be another problem somewhere in this monitor. There must be something that's open, but it's very surprising that this control doesn't work. We're up at 300, over 315 now. I'm not going to keep going because I just don't want to turn it too much where the little slug comes out. Now, looking at this PCB here, I'm trying to see if I see cracked solder joints, and this is the flyback transformer right here, and just trying to see what this is going on here. Some kind of like conformal coating on the bottom. That's a bit weird. Looks like a couple of these might be cracked, actually, like that one right there. So I think I'm going to reflow all this stuff here around the flyback and these things right here in the horizontal section. And let's see if that makes any difference. All right, the solder has been reflowed around the flyback and also around the width control there. So I think the monitor is plugged in. Yes, it is. I'm going to turn it on its side like this. It should be fine. And I'm going to see if that control now does anything. Okay, monitor is powered up. Let's see if I did anything at all, and I'm probably not going to find... Oh, it fixed it. Okay, so I don't know if me adjusting that adjustment is what fixed it, but it is now looking correct. And if I turn the width control, it absolutely is having an effect. So yeah, I absolutely was turning that control all the way back and forth earlier, and it wasn't having any effect. And I don't know if just moving it had the right effect or the reflowing of those joints. So I'm going to put the monitor, put these covers back on and put it back down onto its bottom so you can take a look at how it looks. Anyhow, there it is. Let's turn off these studio lights, make the screen a little less washed out. Take a look at that. It's now looking so much better. Now, one thing about this monitor, and I remember this because I remember from the other one that I worked on most CGA monitors, you could control the difference between the intensity colors or the intense colors and the non-intense colors. Usually there were two knobs on the front. That's not possible with this monitor because of the way it works. This PCB right here is what converts the digital TTL signal to analog RGB, and it also converts that XRGB into analog RGB as well. So all the conversion is happening on this board. And unfortunately, you can see there's a couple ICs on there. There's just no way to control the difference between the intense colors on this and the non-intense colors. So what you get when you're looking at the CRT with the way the CGA color looks is just how it looks with this monitor. This little board is what's handling that brown conversion and all of that. And let's just say it doesn't look perfect. Alrighty, so I think I have this monitor pretty much adjusted as good as it can get. I'm just checking what it looks like there with the shadow on it. Geometry looks pretty good. The only thing I'm noticing is it's a little narrower at the top than at the bottom. And I think that's because the deflection yoke is probably just not perfectly installed on this CRT. Typically you would fix that problem by moving the deflection yoke around, but when they put this monitor together, they glued the little wedges in, and that's pretty much not something you can adjust after the fact now. So not much we can do about that. But otherwise, it's looking pretty good. I put the latest version of Jim Leonard's CGA compatibility tool set on here. Let's take a look here. Oh yeah, there's a bunch more stuff in here. Interesting how this test pattern looks like it's shifted over to the right a little bit. That's kind of interesting. Also noticing that the color temperature of the white, I don't absolutely love it. Looks like the blue is just a little too low. I'll turn up the blue cut a little bit, just to whiten that up a bit. Okay, like that. I suppose this is shifted over a little bit, so there was a position control here. There it is. There we go, that looks a bit better now. This is one of the test patterns that Jim added for me. Specifically, I wanted to have a full 16 color test pattern showing all the different fonts and all the different light and dark colors. So we can see here that the brown, again, is not really that great, but we can really, I can see, at least with my eyes, how much dimmer the right side of the screen is. So the yellow looks really bright, and then it fades over here to kind of darkness. Let me switch the switch on the back of the monitor, switch it into Apple II mode. There it is. Obviously the sync's not working. I think it uses composite sync or something. If we're looking here at this screen and we switch this into Apple mode, notice the blue is now red, and that's just the difference between the XRGB and the CGA. Here's one of the 6845 compatibility tests, the row reprogramming one, which gives you like a pseudo 16 color, well, high resolution, low resolution text mode. And let's look at the test pattern. There we go. That's one of the new test patterns. Take a look at that. That is CGA generating that. Isn't that awesome? Jim Leonard, aka Trixler, is one of the coders for those incredible demos like Area 5150 that recently blew everyone's minds. I think it was in 2022 at what the CGA graphics adapter can do when combined with an IBM 5150. And I mean, this is an example of that. Look at this. If I saw this back in the day, when I knew CGA was so junky, I would have been blown away. This thing looks vibrant and colorful. I think another problem with this monitor is it supports light gray, but the dark gray does not work. So that's the black color here. This should be dark gray, and there's just nothing visible there at all. So I think it's that little conversion board that's just not doing a perfect job at the conversion, which is why brown also doesn't look super good. All right, the monitor is all back together, and yeah, it's looking really good. I have to say that the conversion from TTL to analog doesn't look super great. It's kind of like oversaturated and also a little bit dark. I'm used to how the Planet X3 title screen looks here on EGA, and yeah, it doesn't look quite like this. Although this still looks pretty good. Can you believe this is a CGA monitor connected up through TTL, looking like that, showing all those colors? That's the power of dithering right there. So that's going to be it for this video. I want to just take a quick look at this monitor, and well, we did, and things seems to work, which is really exciting for me, especially because I've never had an Apple II or Apple III RGB monitor. And here we go, I do now. This thing is awesome. It's in really, really good shape. There's just like ever so slight amount of yellowing. I think it's on the right side here. Yeah, I think it's on the right side. It's so minor, I can hardly tell it's even there, which is pretty cool. Considering this monitor is from 1984, it's pretty small, and it freaking works really well. I'm not totally sure what fixed my horizontal size control, or whether it was just me fiddling with the control quite a bit, or reflowing those solder joints on the bottom, but whatever it was, it works now, and that's all that really matters. So I guess that's it for this video. If you liked it, thumbs up. If you didn't, you know what to do. Comment down below, subscribe if you haven't already, you know, all the usual stuff. Check out my main channel if you haven't already, and a huge thanks to my patrons. Their names are scrolling beside the screen. You can become a patron at the link in the description below, and you get early access to videos when I have them done in time, plus some other behind the scenes stuff going on the channel, things like that. So that's going to be that. So stay healthy, stay safe, and I will see you next time. Bye-bye.